So thanks, folks, for listening today. And as Chris said, I'm the Chief Technologist for Red Hat and focused on service providers. And I'm going to spend some time talking about how we use software to actually build and create all kinds of service provider networks. And the best way to do this is to actually look at various examples of customers that are deploying these kinds of things and walk you through the technologies in play. So, kind of what we see around us, everywhere we go, every industry is being disrupted by over-the-top players of all kinds of things. And this collection of technologies is really what's kind of at the heart of where networking is going. And as many of you may know, our company, everything we do is open source, and pretty much all innovations that you look at in any category, artificial intelligence, AR, VR, the new world of serverless, security things like blockchain, and of course, the mobile networks and the edge networks is all, people are leading that work using innovations from open source. And it's interesting when we look at, the world of 5G, sort of our next gen, radios out there, it's not just, about those radios. It's not just about the speed. It's about changing the services for broadband, for enterprise, smart vehicles, telehealth. I can control machines, in mines. And a really important one is we've kind of got a different word for artificial intelligence. The way I look at it is it's called machine-enhanced human learning. So I'm actually using machines to enhance how we as humans learn and take advantage of that together. Right? We don't replace the human with the machine. We actually combine the two. So Charles talked about open source. And I could put a slide up that has probably, technically it's about 1 million open source projects on the planet, right? I could take one from just, the Cloud Native, Foundation, and it would have all kinds of little bubbles on this slide of about, 1,000 of them, different projects. So when I look at the service provider business, they have kind of categories if we look at the stack of, building a network. You've got the infrastructure at the bottom, whether it's the mobile infrastructure, the compute, the networking pieces, and then kind of everybody's trying to move everything to the cloud, including the service providers. And we all know most of the main projects in that category. OpenStack came along quite some time ago in the IT space. Fairly recently, we've had Kubernetes come along, and there's a couple of interesting numbers on this slide. The 97% and the 95% tells us how fast this world is changing. So in the last few years, 97% or 95% of the code of those two projects have changed. Almost completely rewritten in the last 3 years. So that's how fast these kinds of things are changing. And then what happens is there are lots of smaller projects that come born out of those to go solve different problems, to open up different parts of the stack, right? And these things just try and make it easier to integrate multiple vendors, multiple applications at each layer in the stack, right? We just talked about how we use, REST APIs to configure network elements. Well, how do I actually manage these things? So we've got projects like ONAP. A very important thing that people are using to complement all those REST APIs and things people use to configure networks is something called Ansible, right? That allows you to automate any process, which includes a process to set up a server. That's where it started. And now I can use to actually automate the process of configuring a network. So I can actually combine that netconf yang stuff with Ansible and configure entire networks with it, right? And then actually log it, secure it, et cetera. Some other interesting ones as we go higher up into this is as you build these large services, we actually have to be able to integrate them together. And that's where this group called OPNFV has come along to build out ways that I can interconnect these elements in these architectures, verify them, and make sure that they can be implemented in any global network that's out there, right? So these are just some of the ones that are in the picture, and as I say, we kind of support them as they fit into different architectures, and I'll walk you through some of those. So just to kind of, think about what serverless is, right? So really, kind of the thinking here is that developers don't really want to worry about what's underneath, right? They don't want to know what hardware is there, what network's under there. They just want to be very happily developing their code at the top of the stack, right? And that's really what serverless is allowing them to do, right? And what you need to have is open APIs down below that, and on a platform and open source projects, things like OpenWhisk, the Knative projects, And this allows us to let the developer work way at the top, and I can actually build and run his application on pretty much any infrastructure. And think of it like a utility, right? So basically it's like, the water utility, electrical, whatever, that's really all this infrastructure is underneath. Now, of course, we need to make sure that we have open interoperable APIs all the way up and down this stack to the underlying hardware from pick your vendor, Dell, HP, whoever that makes the servers, right? And the networking piece is underneath, right? But that's really kind of the key to being able to build applications on top of a network and not really understand what's underneath it. Now, we can't forget about the security side of the world. So blockchain is a very important piece for people building financial type things. But in the service provider case, right, their use of this is to deal with people trying to steal services, how I do charging, fraud happening out there in roaming services, people using it for telehealth. And this is where we're starting to take advantage of that. Distributed ledger is really a way that I have a sequence of interactions between these distributed devices that actually say, okay, you have access to this. This is not some centralized place that is a clearinghouse, because it takes actually way too long to clear that, that fraud setup. So this is just a distributed way to actually have that transaction properly secured between the community, right? And so now, in addition to the financial communities that are taking advantage of it, in the service provider space, a lot of them are starting to take advantage of either it's a agreement between, say, somebody in Pakistan and some other country, or it's for them doing interactions for different industries that they want to go serve, right? So I want to go serve the manufacturing industry. I want to charge them differently. I can use blockchain for that purpose. So this is a way to actually configure security into that interaction and transaction for the operators, right? So they're taking advantage of these technologies as well. So now this kind of takes the picture that our customers use to demonstrate what the world of mobile looks like today, and that today is LTE. The world tomorrow moves to 5G. But if we kind of look at this picture, I've kind of made it fairly simple. But on the left-hand side, you got the radios up on the towers, right? They have to come down off that tower and basically become connected to fiber, and then they need to connect into this network. And up until now, most of the devices on the edge of this network are physical appliances, made with software that are, made by different vendors, Nokia, Ericsson, Huawei, people like that. And what we're trying to do is we're trying to open up that radio network so that we can actually use servers at the edge of this network. Because one of the key things as this thing scales out is the cost of appliances at the edge of the network is very, very high to the operator, right? So can I, find a way to do this? So fairly recently, a company in Japan, actually Cisco and Red Hat and a number of our partners built this network in Japan. It's Rakuten in Japan, and they're virtualizing their entire mobile network, right? And they're building a network like this. And what they're doing is they're using effectively cloud hardware underneath for all aspects of this architecture, all the way from the left-hand side of this picture to the right-hand side, right? We're talking, just so you give a sense of the scale of this thing that they're building, in the central sites, they have somewhere close to 250 racks of servers. Right? That's the size of that infrastructure just in one site. I move to the middle sites, I got 15 or 16 racks, and I've got many, many sites. Then I get to the edge, I've got 10 to 20 servers worth of hardware solving this problem. So that big blue line across the top of this picture, called cloud orchestration, that's a collection of software from Cisco, NEC, and Red Hat to automate how I configure and change this network on the fly. Right? So they can actually do this automated such that they can spin up a new site and a new service in minutes without sending somebody out to go do it. Right? So this really is changing the time it takes to roll out a new network. Okay. So one of the things that's happening in the world is that as we move to from LTE to 5G, right? The next thing that people are going to try and do is how do I build that new 5G network? So there's new radios, right? And then there's the platform that people use to actually, when you make a phone call, data connection on the internet from your phone, it actually has to get authenticated by some device somewhere in the network. They call that device a packet core. So we need a new version of that packet core, new version of all the devices between your handset and that internet. And so in the world of 5G, we're going to attempt to change that architecture and make it so that I can run that in what we call a cloud native mode. And so there's a project in OPNFV called the Virtual Central Office, and we spent some time building a standardized architecture to deliver business services and consumer services. And now we're going to demonstrate in November in San Diego at KubeCon, a cloud-native conference. We're going to demonstrate the next generation of radio technology from 5G in one location, where the new radios are, the new 5G core, and then kind of the complementary 4G, 5G cores. And the world that we're trying to move to is we've been using virtual machines for almost everything so far, except in the IT space. They've been using containers and microservices for a long, long time. The network side hasn't gone there yet, right? So basically the applications that provide networking are still really either appliances or in virtual machines. And that doesn't give us the scale we need, doesn't give us the flexibility to actually spin these things up and down as fast as we want them to do and scale them. So we're going to actually demonstrate this in a cloud-native mode at this conference. So we're getting applications from some partners, people like Calum, Nokia, Lenovo are going to actually provide the applications on top of this infrastructure and demonstrate that I can build a cloud-native, fully microservices orientation of a mobile network. Right? This is very much the edge of where we're at, because if I go to any of the vendors who actually make these platforms, right, they're still in the lab today with their next generation 5G cores. Because all the 5G that's out there right now, we have new radios, they live, right? We have some appliances that connect them to the core, but the core that they're using today is still their LTE core. They don't have the new 5G one out yet. It's going to come out sometime next year. So we're actually going to show that we can do this in demonstration next month. And if you want more information about sort of what's going on there, you can see the URL on my slide there that talks about this demonstration and the work that the community is doing. Because again, this is a community project, not just Red Hat, but Red Hat and the community showing how do we actually evolve to 5G and take advantage of cloud technology. Here's a nice one. Oh, I like that slide. Oh, that's perfect. Oh, there we go. We're going to back it up. All right. So one of the things I wanted to kind of mention is that this thing we call sort of deep learning. I lost a couple of slides on the way there. I'm going to see if I can go back. This guy. Let's go see. Let's go see. We'll back it up. Oh, I love it. Somehow a couple of my slides died, but that's okay. I'll live. I love it when you put your slides up on somebody else's laptop. Anyway, but effectively we lost 2 slides in the middle of that presentation. So I'm going to talk to those without the slides. You'll see them on the PDFs. So the first one I want to talk about is a customer of ours that is delivering services today for their for the business side of their life. So basically it's VPN service, mobile services, and that's being all built on virtual machines, as I said. Now what they've now decided to do on top of that is take some technology from some of our partners, Cisco, Nuage, Ericsson, etc., and put those applications into a cloud-native platform and then deliver their security services, their music services on top of that. And unlike most service providers, the place they decided to actually put that service is not on the Orange network, right, that customer. They're putting on Amazon. So most of us don't buy network services from Amazon, right? That's not who delivers those, right? Because a public cloud is really mostly for web applications and things like that, right? But the reality is that you can actually deliver networking functions, network services. And actually, I think my colleague Charles from Cisco probably knows this number as well, that if you want to go buy a firewall and actually go spin it up, you can go get one of those on Amazon, one of those iOS, Cisco ASR, type platforms. You can actually get one of those, probably about 500,000 of those running in Amazon today. However, they're configured by you, the enterprise customer. They're not served by Amazon. You still have to configure them yourselves using whatever tools Charles told you about or whatever else you need, right? But in this case, the customer is actually saying, okay, I'm going to deliver my services, and instead of using my private network, I'm going to put all that stuff on top of Amazon. That's what they're going to do, right? So we're going to switch over to AI for a second, and I'll talk about a couple of other customers. So one of the things that people are looking at is how do I actually take the information that's in the network because I got this, you saw those very complex diagrams, got all this data. How do I actually reconfigure this network on the fly, build new services? Why don't I take some, machine learning, functions and actually take that data and use it to actually change how my network configured, how I put up new services. So basically I'm putting effectively an AI platform on top of my network, right, to actually pull the information out. Actually, we talked about this yesterday, asked the question about whether or not the data scientists were actually just scanning all the data coming out of the network and actually trying to parse it all. Well, the reality is what you need to do is decide the information I want from the network are these things, right? Go get that information, go run your algorithm against it, and then actually use that to reconfigure and reprogram your network. So that's really kind of what machine learning and deep learning allow us to do, right? And so this is one of those applications where we have a hospital, that has said, okay, what do I want to do? I want to actually improve how quickly and how comprehensive I can actually look at brain scans from many patients in many hospitals, right? So really what they've done is they've said, okay, I want to actually, so while the doctor can typically look at a brain scan in about 15 minutes, in the same amount of time it takes her to do that, she can actually go get the information from a whole bunch of other hospitals. It's securely delivered back to her location across this network, and allows her to actually have visibility to what those brain scans are, so you can say, you know what, I think this patient actually has this very specific issue, right? They can actually treat it a whole lot easier. And so what they're doing is they're taking advantage of compute technologies and programmable networks that actually interact with in a secure manner between those hospitals. Because the other thing about the data in the world of healthcare is that I only need to get the data that is respective of what's in the brain. The data about who it is, what their age is, where they live, all that stuff, that data doesn't come across. It's just the actual information about what's in the brain scan itself, right? So they can actually compute all this information and bring it across, and what they found is they've actually giving much better care, to the patients, whether they're children, adults. This is a way that they can actually take advantage of this technology. And the key here is that it's, we're not, removing doctors, we're not removing nurses, because they still have, the job that we all need them to do, which is to provide the empathy for us as patients, but we're using technology to accelerate and improve how they deliver that service to you and give you better care. And as I say, all of this type of technology is running on top of a programmable network, right? It's using cloud technology, using network technology, using AI to combine these things. So really it's about using software at all layers of the stack to deliver an improved service to you and me. And before I get into this one, one of the ones I wanted to kind of show, it's kind of one I ran into a while ago, is that most of us all have these, and some of us have cars. In fact, there was somebody showed the Volkswagen yesterday on their slide. The one I was going to talk about, I happen to have a BMW. And so BMW has a really nice application in the car called Connected Drive. And they've had that thing for about 20 years. And it's grown over time, and it's needed to get kind of improved. And they weren't actually able to keep up with the millions of cars that were out there that were connected to their network, right? So what they've done now is they've kind of migrated that set of applications, to a cloud-based architecture, and they're running millions of connections a day where people are saying, okay, where's my car? Lock my car, sound the horn, whatever, all those things that you need to do, or connect you to other applications from them. And interestingly enough that, so it's really good at talking to the car, at least as long as the car is connectable, right? As long as you've got LTE in your car and they can find your car that way. But I had my own experience with this particular, recently purchased car. It was a used car, so it wasn't a brand new one, but it wasn't actually working. So I had the app on my phone, and I tried to talk to my car, and it didn't get there. And I could see that, the message going out, getting up to the web, and for some reason it looked like the authentication of me as a person wasn't being recognized by BMW, because I was still in the old system. I think what I learned after, digging into it is that this old system hadn't been fully migrated to the new system, so they actually couldn't take care of it. But the challenge I ran into was that when I called in, call centers from BMW need some work, right? Because I would get somebody, they didn't understand what I was trying to get at. right? They kept trying to bump me to this person, to that person, to that person. So, the folks that were talking about how to improve call centers and how they can improve our lives, BMW needs to do some work on that one because they didn't actually solve my problem for almost 7 months, right? So that's not exactly, the kind of thing we expect out of, high-end cars, that they're going to solve your problem. They fixed my car, no problem, and take it to the shop, but a web-based network problem, they passed it around and, all over the place. So really important not just to think about the networking pieces, but what's the human interaction with your company that you need to make actually reliable, right? So, if I take sort of that picture of, what I can do to reprogram a network. So what I've got here is a typical way that you could take the network, and the way that we kind of look at a service provider network is in actually three pieces. So most businesses, whether it's a bank, a car company, whatever, they've got really two platforms in their world, right? They've got an applications platform where they run their applications, and they got a data platform where they run all their data. They don't really care about the network because they buy that from somebody else. But a service provider, they've got the data, right? They've got their network along the bottom. Could be physical, virtual, containerized, whatever. And then they've got their applications on the right-hand side, whether that's their IoT applications, their billing systems, their analytics, their security applications. All these things run, in the service provider on his application platform. Now, the challenge they have is that between the data that they want to have for their customers and their services, they've got this network, and they've got lots and lots of data that's coming off the network. And they also need to be able to, on the fly, change this network without even thinking about it. So that's why they built this system in the middle. Now, what that is a closed-loop system that allows them to actually pull information out of the network and change the workflows on the fly, run analytics, run artificial intelligence on it, and then push changes back into their architecture in a consistent manner. Right? So this actually is almost like a CI/CD pipeline, a DevOps application pipeline for the configurations of their network. Right? So this is how they've taken advantage of artificial intelligence and other application software to control their entire network. Right? So this is kind of where, this is the evolution, if you will, of how you actually take a environment that was very focused on applications, for developing things, and apply that to the configurations and the provisioning of a network. Right? This is how the operator is taking that level of work, because, as I said, they've got all these physical devices, they've now got all these virtual ones, now they've got these cloud native ones, and they need to actually control any one of them in the same way and tie that to their billing system, inventory system, call records. All those things need to be tied together and look very much like a DevOps application space. And if we think about it in real terms for the operator, the way that they actually do these things is even, just like in developing applications. What do we got here? Having lots of fun over there. Anyway, so even just like in developing applications, when they go try and put a new service up, they have a development location for that service. They put it up somewhere in development, right? Then they put a test scenario up and say, let's go test that thing, right? Then they put it into pre-production to go test it with a few customers. Then they say, okay, it looks okay, let's actually turn on some serious customer. So they actually have 4 different places they need to test how this network works before they actually unleash it on you and me, right? So they actually have to apply this process to those 4 different environments for any service they deliver. Yes, no. We'll just go this way. There we go. All right. And so one of the things that some of our we're partnering with a university in Boston, and we got this project called the Open Data Hub. And what this is doing is taking a platform to combine data information and machine learning to actually take advantage of these technologies to deliver new services across this same architecture, right? So this allows people to collaborate, build out new services, and that way people that don't have access to, kind of like we just heard about a place to go called DevNet, right, for testing things out that's free and available to you. The Data Hub's kind of a similar thing for letting people test AI relative to networking, right? So that's kind of what we're doing, is showing how that architecture can be built to take advantage of data for a cloud-based architecture. We'll just go this way. And so if we sort of take that, that picture I just showed you and say, okay, I've got this new data hub for the information about the infrastructure. I want to actually take that, and the architecture of the network is going to change significantly. Most, for now we've all kind of thought of, okay, the data centers are centralized, the services are centralized, but now as we push the speed of the network, higher and higher out to the edge, with the next generations of, we've already done it with, cable technologies, optical technologies. We've done access networks of different types, but now we have, with the advent of 5G and the speed it can bring, I can deliver more services at the edge of the network. But what I want to be able to do is take that information, go build that service at the edge, and push that artificial intelligence back and forth across these, think of them as edge clouds, that's saying, okay, I've got a telehealth service, I got an AR/VR service here, I got a content delivery network service here. How do I actually run all these services to all the edges of my service provider network and manage and control those things, right? So really have to have that intelligence distributed now, not just in that central place where I'm doing certain calculations for provisioning, right? I want to actually control this service at the edges of the network. Right. So this one really kind of pushes the envelope of where the service providers are going next with what they want to go do. So what we've kind of talked about so far in what most of them build is in the middle part of that picture, right? That private on-premise cloud, right? So that's how they deliver a business service, a mobile service. They're going to push that to the edge. But as you can see, they've got their data platform I talked about. They got their applications platform. But you'll notice that they're not going to just sit around and say, okay, Mr. Amazon and Mr. Google are going to go take my customers. He's going to actually take advantage of public clouds to deliver his services, right? He's also got, for people that's still running on bare metal machines, he needs to be able to deliver some capabilities there. He's also got his own network. That's kind of the, one of the very far right. That's the physical one, and he has to take advantage of programming technologies, API gateways between all of these clouds, all of his platforms, and actually run that management as code between his pieces. Right? That's what he's really got to be able to go do. Right? So this is really kind of the evolution of their architecture. So it's not just his network, but he's actually interacting with public clouds, as well as his enterprise customers, as well as you and me, across this architecture. So you can see that the programmability of a network in the context of a service provider is a huge undertaking to them as the evolution of physical to virtual to cloud native happens. And I think I'm just about done. And so really kind of what, the building open platforms like we just talked about, it's really about being able to deploy any application anywhere, right? People want to have access to whatever they need, anytime, anywhere. I want to be at the beach getting services. I want to be, in different countries getting services. And, if I can program these things in an open fashion, I've got the freedom to actually, and the confidence to actually accelerate how fast I deliver them. Because really the key thing to the service provider, and almost any business, is he who gets there first and fastest gets the most revenue, right? So if you actually don't get the market quickly, you actually lose opportunity. Your competitors actually take the business from you, right? So they need to be able to do this very quickly and be confident, and they got to be able to secure it, right? Make sure it's secure for all of us to use, and do it at scale, right? And this is really kind of the thing that Red Hat's working on to drive the, the reduction in risk and the ability to drive these applications that change the lives that we live in today. So that's what I had to share, and I'll be happy to take questions. Thank you.
Okay, thank you very much.